Welcome again to my YouTube channel Codes Nest. Hope you are enjoying my videos. If you have still not subscribed to my channel, I request you to please subscribe to it. And as you are aware, we have covered very important topics in Python programming language, the language of future, right? Used for AI. Now we have learned how to use variables, how to use user input, get input from user, how to use personalization of RGB colors, XY coordinates, conditional loops like if, else, elif. So today again we are going to this project rocket launch, right? So in this rocket launch project, what we are going to learn? We are going to learn how to use images for animation, how to use for loops. So these things we are going to learn, and let's start. As you are aware, we are working on raspberrypi.org path, right? So this project's raspberrypi.org dot, right? This is Python introduction path, and we have completed Hello World project. We have completed target practice project, and today we are going to start rocket launch project. So you can log in with your teacher provided ID or your own ID to collect badges, right? I am starting without login. You can start with login, right? I recommend that. So you can collect the badges, right? Okay, let's start this project. And when you will start this project, see, you will be able to see this screen. So this, there are different types of orbit positions of rocket. Here mission is failure, it has unable to reach there. And here, although it has reached, but it has consumed lot of fuel is available with it. And here it has optimized and mission is fully 100% success. So best amount of fuel we have to provide. And let's now see how our project will look like when run. This is provided by Raspberry Pi. See how it will look like. So it says how many kilograms of fuel do you want to use? Let me say 20,000 and press enter. See, rocket is launching, good. And it has reached, oh, mission is failure. Okay. So I have to now run it again. So let's see now run. Say I say 25,000 kg of fuel, right? It is also showing how much fuel is left continuously, right? Smoke is also there. So many functions are there, right? So our mission is success. Now let's start this project and go again. Set the scene. You press set the scene and set the scene. Raspberry Pi provides us with project template. These are badges which you will get after login. Please log in. So project template, we press it and Raspberry Pi provides us with the starter project. In starter project, he has given different blocks, commented blocks. Means these lines will, this hash means these lines code will not be executed. This is in Python, right? So even there is a function, start def startup and def draw, but not written. We will going to write at the end. There is run function. It runs the projects. Okay. So let's start with our first line of code, which we're going to write here. So first thing which we are going to write is for any code is to draw our scene canvas. Canvas is a dimension is pixels. We prefer now 400 by 400 pixels. To do that, we'll set the screen size equal to 400 and we'll do the variables also here. Set up global variables. First variable which we are going to start is screen variable. Screen variable screen size. Okay, the screen variable of screen size, let us fix it to 400. What does it mean? It means 400 pixels. Okay, after defining 400 pixels, we will immediately go to setup and size will be 400 pixel by 400 pixels. So screen size by screen size. So we'll write size. So it will be screen size. So it is, recommending also we'll use it. And again screen size. Again screen size, right? So what will it do? It will give me a canvas of 400 pixels by 400 pixels. Why? Because screen size is, I have already defined screen size as 400. Now next thing, I am to choose an image. So Raspberry Pi has provided us, in addition to P5 library, it has provided images also in this starter project. So we have these images: orange planet, planet PNG, moon.png, rocket.png, and purple planet.png. Whatever image you like, you can use it. I am going to use first planet.png and then rocket.png. So let me go back to screen and set the size of this, as medium of my this font size so that everyone can see it properly, right? So let's now run. Now I've set the screen size to 400. After setting the screen size of 400, I am going to create image mode, right? So image should be in center, bottom center. So first I will start image mode. So where would write? I will write in the definition again, go to setup, and here I will write image mode underscore mode. So it will write all our images. It will set all our images in the center. We are using American English, so it will be center spelling will be like this, right? So next it will do. Now we are going to add a planet also, right? So we'll first define a variable named planet. So it will be indentation will be here. So this indentation is changing. So indentation is very important in Python, right? So here also again, so it is changing size screen, right? So we have to set again it properly. It is not changing. So what we have to do for that purpose, we'll do set animation. We are doing it properly. Okay, let's see what can be done. So we'll put it here. Okay, so now we'll now to improve the indentation, we have to see now indentation is working properly. And now we'll put global also here. So global, we are going to define planet as a global variable, and after defining it, we'll load the image of planet from our library. We have noted the path is planet.png, so we write planet is equal to .png, right? So this will load the planet image on our screen, right? After we have loaded it, our choice, you can choose another orange planet or whatever you want, or right? So this is, there is an option. See, there is, again I'm showing it, there are a lot of options, right? So to choose your image, right, you can do like this, right? So now coming back again, we have, after we have chosen our image, I am choosing planet.png. So next thing, I have to draw a background. In draw a background, what I am going to use, just see, I will go to draw background function here. So first thing is, see if RGB colors are used. So if we write 255, 255, 255 is RGB, all colors are to mixed properly. But if I write simple one column, say for example I write here, I will first of all I will define draw background, define draw background. I am defining the function draw background. Okay, so this function is defined, and don't forget to put a colon here. So indentation automatically comes. I will now give a background, right? So background will be 0. What does it mean 0? 0 means all these RGB colors are 0, right? So it's a short form of 0, 0, 0, right? I can also write like 0, 0, 0, or I can simply write background 0. These both are same, right? So this is function. Now I am going to define the coordinates for this my image. Image I am going to draw right now. See how can I draw image, and with this I have already defined the planet, right? So planet I have defined where I will be getting. So this planet will be defined. Then I'm now giving it size dimensions, right? So which fits, right? Now I'm providing height also. So okay. So these are the coordinates which fit my planet image on screen, right? So after I have fitted them screen, now I have defined this function. I have to call them. Where to call? So which I will go to one function. Here is a written things which I want to do in every frame, right? So which I want to do in every frame. So I will be here. Okay, I will write here. Okay, things which I am going to write in every frame. I will write it here. So for remembrance, because indentation I will use this stroke for indentation so that I properly indent it. So I will say draw, call my function draw background. So it is suggesting me, I will take it and put a, now I need not to put a colon. Why? Because I am simply calling the function, right? So every frame I am going to call this function to draw the background. Next, right? So I will run this code to see if my function is working properly. See, this function is working and my background is drawn. This is right, this color, and this is my planet. So this color RGB00 I have chosen. So it is giving me black background. So I think you are understanding with me all these codes. This is very interesting. Global variables we define for defining any function which can be used outside also. These are variables. We have learned it, right? So print statement also we have learned it. So now what we are going to do, we have to draw a planet. Planet we have drawn. So we have to draw a rocket now, right? So rocket.png. See, we have seen this. See, rocket.png. This is rocket.png. So this image we are going to use now. So to use this image, again we will go to setup, and we have defined global planet. We will add here now rocket. Okay. So after defining rocket, as we have given this planet draw planet definition, so we will give definition for rocket also, location, so that it can load it. So rocket is equal to load image. Again we know what is rocket.png, right? We have done it. So now we want that our rocket should also fly. How we can start that? How can make the rocket fly? For that purpose, we have to give initial position of rocket. To give the initial position, we have to provide a variable of initial position. So vertical position we use y-axis. So let's name our variable as rocket y. So and see, as we have chosen this position 400 by 400 for this size is 400 by 400. So we will choose for this purpose set the center position, right? So we'll go to center position at the bottom, 400 by 400. This is 400 downwards. So we'll go for rocket y. So where will we going to use this? Can I tell? In the beginning. Yes, we'll go to the beginning, and where we have defined screen size equal to 4, here we'll define initial position of rocket. Rocket underscore y, this is equal to screen size, right? So what it will do, it will bring rocket initial position from bottom, and here we have loaded the images also already. Here you can see rocket.png and planet.png, right? So now after doing this, we have to define rocket function, draw rocket function. So where it will go, we have a different block here. So draw rocket function goes here. So for drawing rocket function, we'll simply, first of all, variable we have already defined, so we'll make it global. Rocket underscore y, initial position, we'll make it global. So before making it rather global also, we'll create here define function of draw underscore rocket, because everything we are doing here is for drawing the rocket, and don't forget to put colon here, right? So this function is global function is under draw rocket. So why I'm doing this, now press enter, it will automatically be indented. So you need not to, because if indentation is even one, just one space here left or right, our program will not work. So for indenting proper, we can take help of pressing enter in the previous line, right? So I use a lot this thing. I forget sometimes I use. Now very interesting function we are going to lift off the rocket. What we are going to use? This is the initial position of rocket. So we are going to, so this function use minus equal to 1. What this function will do? It will reduce this, subtract value of 1 minus from this. The rocket position, its coordinates are given again width by 2, and then this function rocket position which we have used it, right? So we have used rocket y, right? Then we use this position coordinates, right? So this coordinates this image, right? This image with this properties, and we have used it, right? So now after we have drawn the rocket and is given these positions like we have given for planet also, now I provided the positions and coordinates for rocket also, as we just called this function of planet, right? Defining draw background, like defining draw planet, similarly we have to simply call draw background, right? Similarly we have to call now draw rocket. So where we will put definition draw. So we'll go again to definition draw. Here we have draw background we have called, similarly we will call draw rocket, right? So this, see, it is suggesting I will use it, right? So draw rocket will run. So let's now run the code. What happens? See, oh, our rocket has started running. Congratulations, our some project has started working. So now our project has started working. We want to add exhaust effects. What is exhaust effect? At present, see, when rocket moves, there is no exhaust. Something rocket is going and not leaving behind this something trail, right? So how we can use that? We are going for that purpose. We are going to learn for loop. We already learned if else elif loops, right? So we are going to use those also today, but we are going to use for loops also first, right? For drawing shapes in each frame. So let's start. So it is graphic effects we are learning, right? So graphic effects are used in lot of movies, right? So it is very fun, right? So each frame now will use this effects. So for that purpose, so first of all, when we want to use exhaust effects, we don't want there should be any boundary line for exhaust effect, right? Smoke is without boundary, right? It can change, decrease or increase size. So we'll turn off the stroke first. So we'll go here in the code of definition draw rocket, and there after image we have image is there. So we'll use this line and take image downwards, right? So here, right? So here we will add a line. Before starting the code, we'll put a no stroke. Why we have used it? So that our smoke has no boundary. So for that purpose we have used, and now we are going to use the important function, that is for loop. How it look like? Just see, for I in range, we are going to define range, say 25. Okay, so we'll, as usual, we put a colon. So this is our for function, for loop. We are using this for loop inside a definition function of draw rocket. So in this 25 loops, we are going to draw various smoke effects. And how we are going to draw? We are going to use random function to draw random ellipses at various points. Okay, so what we are waiting for? First of all, we are going to draw, if instead of smoke we will add later on. First we will add a simple exhaust of yellow color, say, right? So for that purpose, simple exhaust, and that exhaust changes its color when it reaches top. So first we'll start with for loop and fill color yellow. So everyone knows RGB, what is yellow? 250, yes, 255, 255 and 0. This will fill color yellow, and after yellow we'll draw random ellipses, not one, because this function is going to be run for 25 times. So we'll be giving here random ellipses. For every ellipsis, this code will change. So note down, interesting thing here. Width by 2, then rocket, okay, rocket underscore, what we'll see, very clearly see, just focus here, rocket underscore y, and here, yes, here I have added plus I, small I, right? So every iteration, the position of ellipses, this ellipse, their position is going to change, right? So how it's going to change? I have given different position, right? 8, then 3, right? So it will be now changing with every line. This position will be changing, y position will be different. So we'll be having different, this will be moving forward, right? So different ellipses we'll get. So 25 exhaust we will get, right? Ellipses with this, right? So next, what we are going to image, we have already provided. So this for loop will run. So what we are waiting for? Again, I am explaining this ellipse part, that we have added I, means ranges. This loop will be run 25 times. And for every loop, this ellipse position will be different. Color we have already provided yellow. So let's see this coordinates, how it looks like. See, yellow trail we are able to see here, right? So this is yellow trail. So this exhaust we have added. So what we want to, we want to yellow color, instead of only yellow color, we want to little bit change this color. So right. So how will change it color? So here we have added 255 to 250. So always color will remain yellow of the exhaust. So in 255 we are going to subtract I multiplied by 25. Yes, 25, or say 25 is more, let's say 10. So 10, first in the first loop it will subtract 10, and similarly in the last loop 25th it will subtract 250 from 255. So this color yellow gradient will change. So let's see how it color changes. See, this is yellow changing to red. This whole color is changing to red. See, again, see, it's now not yellow always. Color gradient is changing, more changing. Now we have added animation effect. This is called animation effect, right? By using simple commands in for loop, we have added the animation. So now we are going to create smoke effect. Very amazing, na? It should look like smoke. Smoke color is gray. So for that purpose, we'll first of all, we'll again put we have added this color. So we'll go add here again, right? In this for loop, right? We have added fill, we have done 55 I. So for I. So what we are going to, can we tell? Yes, for loop, for I, we are going to first of all define the gray color. To define the gray color, these are the coordinates, 200 by 200 by 200 by 10, right? So now we are defining the gray color, but defining the gray color will not solve all the problems. We have to draw 20 random smoke ellipses. For that purpose, again, we will put a for loop again here, for I in range 20, as we are going to draw 20 random ellipses. So we'll put a 20 here, and don't forget to put a colon. So here we'll draw ellipses. See, when we press enter, automatically it gets indented. If our indentation is not proper, our code will not work. So ellipse, again, will provide the coordinates and this, right? So here these are coordinates. Okay. Next is again, see, now here we are going to add a surprise, right? So smoke effect, we are going to add random function. In the beginning, we have imported random library, right? Random function from random library, right? So here we are going to use that. How? We'll add width divided by 2 plus random integer. Random function we have already imported, and we will provide the randomness value also. Let's provide from -5 to 5. Okay, and close the bracket. So random we have provided here, right? So what ellipses will be at this function. Now, as this line is going to be little bigger, we'll just scroll it this side. And now for next is rocket. This is for coordinates. Now we are going to continue for other functions also. Rocket position, vertical. This is also going to be for smoke. Rocket underscore y, right? So again, random, we will add random function. This time, for example, say random integer. Say we will add, we have draw random ellipses, right? So we'll write 2050. Okay, and again we'll add one more function, random integer, because a lot of coordinates are there. For every coordinate we provide random integer. Okay, so we'll be provided after 2050. Say we'll say random integer. Please be careful to check your spellings. Even if t is missed in random integer or something, you have added extra some word, it will not work. So in random integer, now 2050, say for example we add 510, or after 510, say we want to add one more 510, right? So these function will draw smoke effects, right? So again we provide a 510 and close the bracket, and last closing bracket is already there. So we have provided smoke effects. So let's now bring this to this side, and our screen is a little bit in the center. So and try to run this code. What happens? Let's start. See, smoke is there. I am really enjoying this. Are you enjoying? See, smoke effect is there, giving a smoke effect. I am really enjoying it, and color is also changing from yellow. Once again, we'll do it because I am really enjoying it, right? So this is doing smoke effect, and color is also changing yellow color. Wow, this is great running. So you can save this project, and after this, you know, we have to do what? We have to burn the fuel, right? To burn the fuel, we have to create a fuel variable. So we'll use a burn variable again now. We'll ask user also. So we'll put it here, rocket y. So here we'll put a variables. All variables are here at this block. We define a burn variable. Burn variable is equal to 100. So it will be defining how much fuel is burned in each frame. So in each frame 100, just defining a kg or some what amount. So this much fuel is burning, right? So this is for that defining. After this, we'll just at the bottom to how many kilo we will ask a user, right? Before run, we'll ask a user fuel is equal to integer and input. Input mean user will, we have learned this function earlier also. The user will be able to tell how many kilogram of fuel do you want to use. Hello, we'll just put here. How many kilogram of fuel do you want to use, right? We'll ask it, and now what we want to check the fuel burning. For checking the fuel burning, we'll go to again global. We have where we have defined global variable, global rocket we have defined, rocket y we have defined. Here we will define these function also. Global rocket y, then fuel, then burn, right? We have defined these variables global, right? And rocket we have already defined fuel. Now here we'll put a function fuel is equal to fuel will, every frame fuel will get reduced. So decreasing, we'll just put a minus equal to 1. So it will keep on regularly reducing. So this will what we're going to reduce? Can I tell? Fuel equal to, instead of 1 we'll put burn here, right? So it will burn the fuel. Fuel is equal to burn. Every time it will burn. This we have defined burn as 100. So it will keep on reducing fuel by 100 amount, right? So minus 1 if you put minus, so it will simply keep on reducing 1, but we'll put a burn here. So it will continuously put whatever user defines, or we define it here, right? So now after this, we'll also want to keep on printing how much fuel is left. So okay, after defining fuel, we will put print. Whenever this function is called, it will keep on continuously telling that fuel, how much is fuel left. Fuel left, and this will keep on telling how much fuel left. How will come to know? By reading the value of fuel variable, right? So this will do animation. So now, so let's run how it should look. So we'll put it here. Okay. So let's run it. How many kilograms of fuel do you want to use, right? So we must know how much we define. It will automatically reduce it, right? So it has started asking us how many fuel do you want to use. So rocket should only move if it is enough fuel, right? So for this we will use a if statement. Okay, here let's, before running this code, we add a if statement to check how much fuel is left, right? So what is the statement? Fuel is greater than equal to burn, right? We'll check it, right? Burn, say if fuel is more, then only it will learn. Okay, so we have defined global here rocket. So here we'll now add a if. How, when to increment? If, right? So here we'll put a if statement. If fuel greater than equal to burn, right? So don't forget to put comma, and now all this indentation will change automatically. We will want to change by this, right? So print will change indentation. Just press a tab and it will, you can able to change, right? Similarly we change for this also, and this also, this also. Okay, this also, all these indentations are changed because we have put a if loop here, right? So similarly this will going to change, right? Now for loop for ellipse. So ellipse will be changed, and now image will be still remain here because this loop is out of this loop, right? So now if what we want to do, if we run this program, what will happen? Can anybody guess? Let's now run it and see ourselves what will happen, right? So stop and run. So how many, again it asks how many fuel, kg fuel you want, right? For example, what we want, say we put a 400. See what it happens. See, it says 0 0, right? So we'll put a more here. It's less. Run. How many say? We put 20,000, right? So run. It goes like this, right? So this is fuel left 0. So keep on decrementing. I'm really enjoying this. So wonderful, right? So rocket has stopped when our fuel is run out. Earlier it was not stopping. You have, congratulations, you have done a great job. Your rocket is able to stop as soon as this. Why it is done? Because if loop is there and for loop is also there, right? So according to fuel left, this function will work only this. Now we have to reach a orbit. So to reach a orbit, we have to draw a orbit line also. How to draw a orbit line? We'll go to 11 here, global variables again. So in global variables, so we have defined burn is equal to 1 0. Here we will define orbit radius first. Orbit underscore radius is equal to 250. Okay, and then we'll again, as we did earlier, we'll define y position by defining orbit y is equal to screen size minus orbit radius. Orbit radius, this is our, we have defined it, right? We are defining the variables now. Orbit screen size, we have already, orbit radius is there, right? So now in go for these functions, because we have defined the variables, we'll go to this background here. As we defined for others, we'll put it here, right? We'll put a no fill here, again no fill. So turn off any fill. For that purpose, we'll just put a no fill so that our function does not get stopped due to any error. So after this, we'll put a stroke. So to put a white stroke here for the orbit. So we'll use it 255. What we'll do, 255, 255, 255, right? RGB 250, it will create a white color. So then again we'll say put a weight of this, how much thick line we want for this, right? Stroke underscore weight 2. Okay, this we have defined the weight, and then again as we do, we will define the shape of this. So shape is elliptical path. So and again for ellipse we will define all the parameters of ellipse, width by 2, then we'll define height, then is orbit radius into 2 will define. It's here we started giving value which we have defined earlier, this multiplied by 2, and then we'll define orbit radius by 2, then again we'll give the same for coordinates, y position also, orbit then radius multiplied by 2, right? So we have defined this now. So let's run this program to see if our orbit is defined. See, let's see how many kilogram. Again we put it 25,000. Okay, let's see. See, now our orbit is also defined. See, it is now stopping it. So 25 is exactly, it is crossing the outer. If we put again and run it again and put 15,000, what will happen? See, rocket go stops in between. So to reach the orbit, just cross the orbit, we have to put 25,000 fuel. By simulation, we are able to know this, right? So this is now going to check it. Again, we will do. Now what we want? Burn and rocket Y. Okay, and the rocket Y still flying. So we want to check if this is still flying. So we want to put it as a flying. We'll check fuel value, right? So for that purpose, we'll put here if fuel is greater than equal to burn, and we put a and command here. Logic, this new thing we are going to learn. So okay, and also what? And rocket Y position. Rocket Y position, okay, is greater than orbit Y. We have to run the fuel only then until it has reached the orbit. After this, we need not to burn the fuel, right? Okay, so what will it happen, right? Now, for example, let's see now run and put 50,000. What happens now? See, 50,000 means lot of fuel, right? But it uses only optimized resources. This is the beauty of it, right? This is how we can use the commands in Chandrayaan Ditya. When once the target is achieved, we want to switch off the fuel consumption. This is we have done it, right? Congratulations, you have done very good, right? So now what we want, if we want to check if launch is successful, for that purpose rocket should be launched red. If before reaching it, the fuel has gone consumed, then it should turn to red. For that purpose we'll go to finish and draw rocket is there, right? This is draw rocket. Okay, so in draw rocket, so we have done here 20, right? Ellipse is there, we have done. So here before this we have done defined it. Okay, for in I we have given here the range for it, right? So we just if fuel color will be changed, if fuel is less than fuel is less than burn and rocket y position, this is rocket y position. Okay, this rocket y position is greater than, we'll put it like orbit underscore y, right? So if this is the condition, we want to change the color. Tint failure, we want to tell that fuse this whole fuel is consumed, fuel is less than burn, right? Then we'll change 255. Now let's see, run it. Say we'll again put it 20,000 here, and it will, because RGB it will turn to red or no. Now see, it is red, mission is failure. So right, after trying, right? So this is done. So next tint function again, this time to change green if the rocket is enough. So we want to green now. If enough fuel hai, then where we'll put failure after this. This is a failure. Okay, after this elif we'll put elif. We have done it earlier also. So we'll use elif rocket underscore y. It has changed the position, reach the rocket position equal to orbit underscore y. Okay, so then we want to put tint as 0 255 means green RGB, right? So this time 0 to 55 will be green 0. So less than 0, so it will be success for success. So let's run it and put, right? So let's run it now, because it will be it will ask us again syntax bad 29. We have, let's see if it's combined. It wants combine this. Now it's, we have to put combine operator function, right? So put it 50,000 now. So it goes again, and oh, it turns into green. Yes, so it means mission is success, right? This is success mission, right? So it is success. So this is success mission. So now we can accordingly change this mission. If the fuel is 1,000 or greater than 1,000, right? We can change this, right? So this is this we want to amend the conditions, right? So it only turns green if orbit and has less than 1,000 kg of fuel, right? So for that purpose, we can do that. We can test that condition. That we now what we want to do. We want to check the amount of fuel, right? So as much needed to read. Now it is very costly to use so much fuel. So we'll amend the condition in our success code that rocket only turns green if it reaches orbit and has less than 1,000 kg of fuel left. Means it's optimized, right? So that means nobody can take more fuel, right? So for this, we'll again go to, if fuel is burn, this code is here, and we'll add a goal here. If fuel is less than burn, instead of, we'll put fuel is less than burn. Burn and this condition basically, and rocket, this condition will put rocket y greater than equal to y, then it should be total failure, right? When it happens, if fuel is less than burn and this will be failure, then we'll put this one, this will put here, this is failure, control X, and we'll put here control V, right? Now failure. But if elif fuel is less than 100,000 and rocket y is also less, so initially it is greater than, both time it is less than equal to, less than equal to, then equal to orbit y, right? Then what we want, tint of 255 by 0 to 55, say yellow, we'll do yellow, 0. So you have to choose comma. Okay, this is dent for that purpose. Let's check once again. If fuel is less than burn, right? And we have to put and command also here. And rocket y greater than orbit y, then it is a failure. Then L if fuel because it will is a red color, that means failure. L if fuel is less than 1000 and rocket y less than orbit. Orbit it has not reached equal to, maybe it has reached, but it has fuel consumed more than. So we have to put here less than, right? Fuel is less than, right? So next it is too much fuel. Next is too much fuel. It is success only. If greater than, then it is too much fuel, right? So, okay. So now we'll run it our code and test it with, for example, we now with 20,000. What it happens? Oh, mission is failure. Okay, run it now. Let's say 25,000. What happens? Yes, mission is success. And if we put more fuel, say 40,000. So what it left? So it shows also fuel left. So fuel 15,000. So in too much fuel, we have not changed the color. We want to change the color, right? Too much fuel for example, we'll change the color now here. When it uses too much fuel, we'll use different color here. See now, right? See, if we now provide very much fuel, so what will happen? For too much fuel, see, it is not given completely green. It has changed different color, yellowish tint. So that although it is a little partial success, because you have used too much fuel. Good. Congratulations, you have completed your project. Hope you enjoyed this project. I really enjoyed it. I learned so many things. How to launch a rocket simulation, right? You can now imagine how much complex is to launch a rocket, right? So we have learned how to use if statement, else statement. Not only that, how to use for loop, how to change the color, how to learn optimization of resources. You can upgrade this project. How you can upgrade? You can add a new orbit and drop satellite there also and change the colors there, right? So endless possibilities, right? You can put it. So thank you very, very much once again. See you again.